Hi everyone, welcome to week 3 of Stuy Splash. We have FRC Team 1678 with us to give a presentation on electronics, and I'll let our presenter take it from here.
All right, thank you. Hi, my name is Nick Viatella. I have been on, well, this is my 4th year on Citrus Circuits, and this is my 2nd year of being the electrical lead. All right, so, hold on a second. All right, so we're here to talk about wiring and wiring practices today. So why is good wiring important? So the majority of problems at a competition for us come from wiring issues, and so you want to make sure that when you wire your robot, you do it right. And so if you have good and clean wiring, it's much easier to work with, and troubleshooting is a lot easier. If you have a rat's nest, pretty much like this image on the right, this was actually our 2013 robot on the right here. If you've got a rat's nest like that, it's almost impossible to see what went wrong and visually inspect your robot and see if there's a short anywhere or see if anything's burnt out. And so another benefit of good wiring is that repairs are much faster. So say you smoke a motor or something, if you want to take it out, you're going to have to undo a rat's nest of wiring in order to remove it and get a new motor in. So yeah, you're definitely going to want to avoid what's on the right here. So the breakdown for this presentation, I'm just going to go over 1678's wiring process, and then I'll just do some tips for these 6 sort of areas right here. So batteries, the PDP, motor controllers and motors, PWM and CAN connections, the Roborio, and then the radio and line lights. All right. So our process. So during off season, we train new members and experiment with new components because you really don't want to have to train your new students on the fly when you're trying to make your competition robot, because you have like 3 months or sometimes even 4 months before build season starts. So you definitely want to use that time to your advantage. And also, it's a really good opportunity to experiment with like a new drivetrain or a new camera or really any new technology that you're interested in. And if you test it in off season, that allows you to sort of understand how it works and what some of the common problems are and how to fix those common problems are, or ways to solve those common problems. All right. And then once build season starts, it's really important that you communicate with your other divisions on your team. So whether it's talking with software programmers, software robot people, and figuring out what port, say a motor needs to go into, and then also talking with design is really crucial, because a lot of the time, some design members, they sort of forget that like wires have mass and you can't sort of bend it at a perfect 90-degree angle. So it's really good to communicate with design students and sort of help them lay out the belly pan of the robot and sort of help them place components on the robot for the easiest way to wire them. And so also during build season, you want to get as much as done as you can before you actually get a robot. So when you're working with design, you want to sort of see, okay, well, this component is going to go here. Like say the PDP is going to go here, and these motors are going to go here. And so I can sort of estimate how long the wire has to be, and see and get that wire cut ahead of time and crimped ahead of time. And so the purpose of this is to save as much time as you can and be as efficient as possible, because the less time that you have the robot, the more time that the programmers get to try new autos, or the driver gets to get more driver practice, or the more time mechanical has to add new components. So yeah, and then branching off of that, if you have cleaner wiring, the repairs that you're going to have to do are much faster. Yeah, that's pretty much that. And then what you want to take your time when doing, though, is you want to do it right the first time. This is probably the most important part of this presentation. If you do it right the first time, the chances are the chances of having to redo wiring is going to be significantly lower, because I would say when you first get the belly pan of the robot and you're first putting components on it, that is when you want to do it right. There's a time and a place for doing it fast, and there's a time and place for doing it right. Usually doing it fast is say at a competition and you just need to get ready for the next match. That's when you want to do it fast, but definitely repair it and do it right. All right, so we're going to move on to sort of more of the tips section, and I guess we'll start off with batteries. So battery wiring. So 1678, we use MK batteries. We've been using them for as long as I can remember, and we've rarely had issues with them. I'd say we get 12 to 15 batteries each year, and we only have like on average one battery perform slightly lower than others. And so on our batteries, we use 4-gauge wire. You can use 6, but it's a very small amount of mass that you save. And when you use 4-gauge, you get a little bit more performance. So I guess you're sacrificing a little bit of mass for a little bit of performance. But I would say it's almost a negligible amount of mass. So I would definitely just go with the 4-gauge wire. The lug nuts on the battery, you have to make sure that those are tight. Because if those aren't tight, that can just lead to a robot reboot, and you're just going to be dead on the field with your radio rebooting, and that'll be pretty much the end of your match. So you want to make sure that your battery is properly insulated. We prefer heat shrink. It's a lot easier to, well, not necessarily easier to work with, but when you have to remove it, it doesn't leave any residue behind, and there's no chance that anything can get in there. And as you can see on this picture on the right, some teams like to use 3D printed caps to put over their lug nuts and their battery terminals, but we don't use those. We found that just the wires going straight up from the battery works just fine with heat shrink going over everything. So the batteries that we use in FRC are lead acid batteries. So you want to make sure that those are charged to prevent sulfation. And what sulfation pretty much is, it's a chemical reaction that can result in longer charging times, excessive heat buildup, shorter running time between charges, shorter the battery life, and eventually complete battery failure. And so it usually happens on the positive terminal, and it's like that. It looks like battery acid on the positive terminal. So if you ever see that, it's usually a bad sign. You need to try to keep your batteries charged, and usually it prevents that. And so it's really important to understand how well your batteries are performing. So I've definitely invest in a battery beak, and if at all possible, a battery analyzer. You can buy both of those on AndyMark, and the battery analyzer, well, the battery beak, you just plug it in, and it tells you what the voltage is for, it is like, I think it shows you the voltage for the cells, and then it shows you the internal resistance. But what the battery analyzer does is you plug it into a computer, and it basically discharges the battery at a certain rate over time, and you can sort of see how it performs over that period of time. And so not all batteries are the same, so you're definitely going to want to label and keep track of which batteries you've used and which ones are good and bad. I say that because it's going to be a very small difference between the batteries, but like say it's in a finals match and you want to make sure that you're using the best battery, then you'll definitely want to keep track of which one's which. All right, so moving on to the PDP. So like the battery, you use 4-gauge wire to the lugs on the PDP for the same reason. For the Wagos that go into the, for the Wago connectors on the PDP themselves, we just twist the wires before they go in there, because by twisting the wire, you can reduce the chance that a strand will get separated from the rest of them and sort of can bridge over to another Wago connector and cause a short. So some teams like to use ferrule crimps on the PDP connections, but we found that we don't really need them. But you do want to use ferrule crimps on the smaller wide Muller connections, like on the CAN bus connectors and the Roborio and VRM and PCM power. And so you want to make sure that you aren't putting a lot of strain on the ports on the PDP. So you can zip tie the wires that are going into the PDP down right where it connects. And that way you're not putting constant stress on the PDP ports, because if they're under constant stress, then over time they'll weaken and then they'll eventually fail and leading to a disconnect. And so when your motors are, your Roborio could lose power. So moving on to motors and motor controllers. So with motors and motor controllers, consistency is key. You want to have all of your motors have the same lead length, and you want to have all your speed controllers have the same lead length, because that allows you to have, say your robot is like all mini sim, or well, let's say all Falcon 500. That way, one motor can be interchangeable with all the others, and it's way easier to have one motor or one spare motor that fits all of the uses on the robot, rather than having a spare motor for each mechanism. And so the same thing applies with CAN wires and signal wires like PWM. And then you're going to want to avoid flipping Andersons, because when you flip Andersons, there's a, I mean, sometimes you do it out of just ease because you aren't, it's not consistent. But you really want to avoid this, because you can end up making a mistake in like reversing the polarity of a motor. In 2019, when we were testing our crawler for our triple climb, we accidentally flipped the polarity of the motor for the crawler. So instead of pulling us onto the HAB platform, we drove off of it and fell backwards, and that was really quite bad. So it's just one example of something that could go wrong with that. And then some bonus advice: if you're going to use a SparkMax or any brushless speed controller, you want to make sure that it's in the right mode for the motor that you're using. So say you've got like a SparkMax and it's controlling a Neo, make sure that it's in brushless mode. And if you're using it with a mini sim, you're going to want to make sure it's in brushed mode, and you can control that by pressing the button on the SparkMax. Because if it's not, it's going to end up smoking out the brushless motor, and you'll be down a motor, and that really sucks. All right, so PWM and Can Crimps. So these right here on your screen, they're probably not going to look too familiar, because I don't see a lot of teams use these. Most people just prefer the standard 3-pin PWM crimps and Can Crimps. But what these are latching polarized connectors. You can find them on Hanson Hobbies. And 1323 showed these to us, and we absolutely love them. It's so much easier than having to use the like standard 3-pin connectors, because the latching mechanism is really secure, and you don't have to use a C-clip, because we didn't really like the C-clips because there were the Rev C-clips and the Vex C-clips, and we found that the Vex C-clips sort of crushed the signal wires, and the Rev C-clips that came with the Neos were way too hard to get off, and you need like a tool to get them off. But with these, since they're polarized, there's no way you can accidentally flip polarity and or have a dead sensor, or accidentally flip your CAN wires. And so I would definitely recommend purchasing some of these, trying them out. If you like them, that's great. I would definitely recommend using them. But if you're not a fan of them, then yeah, just stick to what you're doing. But with CAN, so with CAN components, what we do is we have one male housing and one female housing per each end of the per each set of CAN wires on the like say a Falcon, and so that allows super easy daisy chaining between components. And yeah, like the motors, you're going to want to make sure that those are all cut to a similar length, and that is just for consistency's sake, so you can swap motors out wherever you need them to be. And then with the latching connectors, you're going to want to put the male crimps in the female housing to protect the male pins whenever it's disconnected. It's just a quality of life thing, I guess. But it's really helpful when, say you have to disconnect something, and you've probably had pins get bent in the past, and it really sucks because you have to recrimp it. But it just prevents that. All right, so PWM and Can Crimps continued. So sometimes we use wire sheath when we've got to run like a CAN wire or a PWM wire through a sharp or around sharp metal. And so what it is, it's basically a mesh tube that you slide over and zip tie at both ends, or you can heat shrink at both ends. And it basically provides another layer of protection for the wire. And so when you have to make a PWM or CAN extension, when you're using the polarized connector or the latching connectors, you need to make sure that one end is male and the other end is female, because then that way, or well, if it wasn't, then it would sort of defeat the whole purpose of the easy daisy chaining. And then since signal wires are the smallest gauge wire that you use on a robot, you need to make sure that they have enough strain relief, and you can just secure them down with zip ties to the belly pan. As you can see, the Holy Cows right here, which are like probably the best, they have probably the best wiring in FRC, hands down. And so you can see that they've zip tied down their CAN wires along the belly pan to sort of protect it. And the less loose wire that you have on your robot, the better. Because if, say, a wire is just hanging around and it's loose and it's next to a drivetrain chain, then it can sort of just slide over and get picked up by the chain, and then just get the insulation would get all rubbed off, and then it could short, and then you'd be down a motor. All right, so let's move on to the Roborio. So what we like to do with the Roborio is cover the unused ports in electrical tape. And so some teams like to use 3D printed like caps. We tried that, and we weren't big fans because chips could get into the Roborio, or well, the DIO and PWM channels. And so with electrical tape, you just get a nice solid seal, and it prevents shorts. And so you're going to want to use ferrule crimps on the wide molar connections on the CAN connection, or yeah, on the CAN terminal and the power input terminal. But there's one thing that the one thing that I don't like about the Roborio is the USB type B port. And so we've had instances in the past where we plug the USB type B cable in, and then you'd wiggle it around a little bit, but then when you try to pull it out, it would get stuck. So definitely be on the lookout for cable getting stuck in the type B port, because if it gets stuck in there, it's really, really hard to pull out, and you feel like you're breaking it. But if it does happen, the only way you can really fix it is just by pulling it out. So watch out for that. And then, yeah, like all other components, you need to make sure that all the signal cables and power cables going into your Roborio aren't under constant stress. So you can just fix that by zip tying it down before it gets plugged into the Roborio. Okay, so radio and limelight. So I would say over the past few years, this is definitely where we've had the most trouble. We had a lot of problems with signal with Ethernet in 2019. Not as much as in 2020, but it was still there. So with the radio, you always want to double power your radio all the time, because if say you're using the PoE injector and it the PoE cable like becomes loose inside the housing, if it disconnects for like just a second, just a fraction of time, then it's going to have to go through a full reboot, and that takes almost 45 seconds to a minute sometimes. And so always double power it is just another layer of protection and reliability. And so the radio isn't designed to be undergoing a ton of vibration all the time. So what you want to do is you want to have it secured to you want to have it soft mounted pretty much. So that can be either with VHB or very high bond tape, or with hook and loop tape, which is just Velcro. And so it just provides a little bit of vibration dampening. And what we did on the picture right here is we had a piece of polycarbonate with part of it bent, so it would increase the rigidity, but also allow for a little bit of shock absorption from the frame. And so that was sort of a way of providing shock dampening to the radio. And so if you have intermittent Ethernet connection issues, like you keep losing your radio and you see it on the driver station, what we did in 2019 was we basically took a tennis ball can and sliced the can, yeah, you buy tennis balls in like those clear plastic cans, and we took that and we sliced it into very thin strips, and we inserted it into the side of the Ethernet housing. And so it would basically just act as a shim inside the Ethernet housing that would secure the Ethernet cable in place and prevent it from sliding around. And that worked pretty well for us. I think we had bought undersized Ethernet crimps that year. But yeah, so with the Limelight, we try to avoid PoE or power over Ethernet, because if it loses power for just a fraction of time, it's going to disconnect and it's going to have to reboot. So we prefer using the wide molar connections that go straight into the Limelight instead of over Ethernet. It's just more consistent and less likely to fail. So yeah, that's pretty much all that. Any questions? I think you can ask them in the YouTube chat, and I will be able to read them and answer them. So yeah, Noah says, do you track battery degradation over time? So at the beginning of the season, we run all of the batteries when we get our batteries for the season, we run them all through the battery analyzer, and then we do it in like 2-month intervals. So we track at the beginning, and then 2 months later we track it and see which ones have gone down significantly. And then those usually we use for like driver practice, but at competition we try to avoid them. At competition we just try to cycle through like 8, or well, not 8. I'd say like 4 or 5 of our best batteries. How do you design your electronic system when you design the robot? Like where to put all this stuff? So we usually try to think about how wire is going to have to be routed. Because if you have to, like, say you've got an elevator, you're going to have to think of a place to like put some e-chain to run that up. But we usually do a lot of communication with the design team and Mike. They're usually responsible for like all the mechanisms on the, or where mechanisms are going to go on the robot. So we try to place stuff in a central location where it's easy to reach all parts of the robot. So usually it all just goes on the belly pan. We're not one of the teams that has like an electronics board that gets mounted to the side or something like that. We've just found that the belly pan is probably the safest spot for all the electronics, and it's the easiest to access as well. All right. Any other questions? You can just ask them in the chat. I'm not seeing any, so I guess I can just wait a little bit longer, see if anyone's still typing anything. Yeah. Well, I guess if nobody else has any more questions, then that was all I had for the presentation. If you have any questions, you can contact me at nviatella@gmail.com and just ask me any FRC related or FRC Electronics related questions. But yeah, let me put that on the screen right now so you can contact me. All right, so yeah. All right, well, I guess that's the end of the presentation. So thank you all for coming. Yeah, all right, one more question. How do you secure the feedback from the Neo motors? What do you mean by secure the feedback? We use the onboard encoder, but I don't really know what you mean by that. Oh, okay, now we've got more people. How have you secured the radio and Limelight in the past? What do you think works best? So for the radio, we have a 3D printed bracket that we rivet to the frame, and then the radio gets zip tied down to that with a little bit of hook and loop tape behind it. The hook and loop tape is sort of shock dampening, and it prevents it from sliding up and down, and then the zip ties just hold it down to that hook and loop tape. It prevents it from just falling off. And then the Limelight, we have another 3D printed mount that holds it on the sides, and yeah, it just gets mounted to the frame with bolts. The cables are short and often need extension boards. I'm asking how you secure them. So we usually we have an extension board, or well, we usually buy the extension cables from Rev, and then we don't really like the boards because there isn't really a good way of securing them down, or of securing the connection in the extension board. So we just solder the wire directly to the Neo encoder cables. But if you mean secure, we just zip tie it down to the frame with zip ties, because on 1678, the fabrication team, they put a 0.5 inch hole pattern on all of the stuff or all of the tubes and gussets. So does your team have like a best soldering practices kind of thing, or do you guys not really solder stuff? We do mostly, we solder a few things, like for surface soldering or through hole soldering, we solder the canifier, but I'd say for soldering best practices, um, I would use leaded solder. You're not going to be ingesting any of it, so you don't really have to worry about lead poisoning, and it just wets a lot better than the lead-free stuff. The lead-free is usually for companies that have to comply with lead or emissions codes, but you're not getting that much lead out into the environment. So I would definitely stick to leaded solder. Then I don't know, just like a general soldering tips would be like always heat your work before you solder, or before you add solder to it. Always tin wires before you connect them with solder. If you're having trouble, add flux. If you're having trouble with solder getting to wet, add flux. Isn't lead solder against the rules? Not that I'm aware of. No, I don't think that lead solder is against the rules, but I can read up on that and then, yeah, because we've used it all throughout the past in 2019, 2018, 2020. So let me see. Um, oh, do you use all the lights on the line light or cover some up? Sorry, I missed that. So we usually just use all of the lights. I think in 2019 we didn't cover them up per se. I think we just had a software robot programmers look at the terminal for the limelight and see if there was a bunch of noise. Then we would turn down or we would turn off some of the lights. But I don't think you have to cover them up. I think you can turn them off in the software.
So if there aren't any more questions, which I don't see, thank you to Nick for joining us today, and thank you to everyone for joining us on this live stream. We'll be having another workshop at 5:30 on how to navigate alliance selection, so stay tuned for that stream, and thank you once again for coming.